Hey guys, so this is our last video lesson for chapter 6. I'm going to plan on the test being next week. I'm going to go over like a little review thing Monday again at 10. We'll just do another live session. You can join if you want next week Monday, just to go over the review, answer questions, make sure you're feeling okay about the test. And then I'm just going to have you make sure you have your test, chapter 6 test, taken and uploaded, or send email or whatever, a picture of your test to me by the end of next week. And that's all we're going to do before spring break. If we get to come back to school next week, then we can take the test in class. But just in case, we're just going to plan on having you guys send that uploaded to me by the end of next week. So this is our last lesson. Like I said, it's on arc length and also on surface area. So let me switch over cameras and we'll get started. I don't know what I just did or how to stop it. This is super cool. Okay. Sorry guys. Okay, here we go. All right, so I did not actually bring a wire or a branch for you, but how you would find the length of that is probably, maybe put a string along it, straighten it out, and then measure it. Or you could find little straight sections, measure the length of each section, and then add those together. And that's kind of how we're going to do this with calculus, is we're going to find the lengths of each section, and then, sorry, there we go. There we go. Find the lengths of each section and then add all of those together. Each section is going to be infinitesimally short, but then we're going to add them all together and get the exact length of the arc. Now, the other question here is if we wanted to paint a bunch of light bulbs, and the spray can says it can cover 30 square feet. How many light bulbs can I paint? Meaning we'd need the surface area of this weird shaped light bulb kind of thing, and how would we do that? And again, we're going to break it up into little sections and add them all together. So you have your formulas for length of an arc and surface area, and it's just that same idea. Here we're finding all of these little tiny lengths. This is kind of like the distance formula, right? Square root of the distance one direction squared plus the distance the other direction squared, Pythagorean theorem. But for every little tiny section, adding those all together. And then surface area, we're doing that same length that we do for the arc length, and then multiplying that length by 2 pi r. And so each of those little lengths multiplied by the area around, adding them all together gives us the surface area. So here's our guided practice. I'm going to put this on another paper so you can kind of follow along as I go. So we're looking at y equals the square root of x minus 1. So it means it's been shifted to the right one. It's a square root function. So 5 minus 1 is 4. Square root of 4 is 2. So when x is 5, y is 2. So that's like right there. It's going to look kind of like that. So we're going to find the length from x equals 1 just to x equals 5. That's where it tells us to stop. Okay, so using our formula here, length equals, we're going from 1 to 5. So it's f prime of x squared, the derivative of our function. So if that's y prime is 1/2 x minus 1 to the negative 1/2. So that's what's going to go right in here. There's our dx on the end. We can simplify this quite a bit. That's wrong. The squared and the -1/2 just makes it a negative first power. So it's like that on the bottom. There we go. Just like that. And then, of course, find that integral. Again, that one I would probably say just do that using an integral calculator. That's not one you're going to necessarily have to be able to do by hand, which gives us about 4.647 is the length of this curved line. So it's just finding each of these distances and then adding them all together. Okay? So that's your length. So we're just going to do one example of that. Now we're going to look at surface area. So surface area, first of all, if we revolve that same line around the x-axis. Oh, sorry, you can't see that. There we go. If we revolve that around the x-axis, what is the surface area of this shape? You could say this whole area in here is filled in or not. It doesn't matter because we're just getting this outside surface area of this shape. Okay. So for surface area, again, we're still going 1 to 5 of so 2 pi r, this is our radius all the way out. So 2 pi r, now it's giving us this whole thing here. And then it's giving us each individual one, and then this arc length is going to make it into the surface area. So this next piece of the formula is the exact same as what we had up here. So you could continue to write it clear out. Like this. Or if you'd rather substitute this in with this, because we already know that's the same thing simplified, it's exactly the same square, oh, you can't see that. Right, exactly the same, so we could substitute this in instead of this, since it's the same thing. 1 plus 1 over 4x minus 4. Either way is totally fine. Okay. And then just calculate that. The next one we're going to look at is this curve that rotated around y equals 2. Not really drawn very good to scale here. But this is our shape. So the surface area, I'm going to side this up so that doesn't go back behind what I'm drawing here. Oh, my camera just died. I bumped it. Can't bump it. My cord has to be in just the right spot or it doesn't work right. It's awesome. Okay, there we go. So 2 pi again, from 1 to 5. This time, this radius piece is not like it was here, the radius was just from the axis to our curve. This time it's not. From the axis to the curve would be down here. We don't want that. We want this. So it's to take away from the axis to the curve. So that's again just that radius. And then times our arc length. This time I'm going to write it in the simplified form. And it doesn't matter. This parenthesis section here could look like this or like this. You're just going to put it into a calculator that's going to do that for you anyway. This piece is always the same. It's the arc length. So as long as we're using the same curve, it's going to be the same arc length. Okay. All right, so now let's look at one more. This time, I'm going to move this paper just so it doesn't bump that cord again. Something below the x-axis. We're going to revolve around y equals -3. So this big shape now, much wider since we're revolving around this bigger axis. Still integral from 1 to 5. This time our radius is this line here. It changes depending on where we are along our curve. So this, from the axis to the line, is our square root of x minus 1, but then we also have this section here that's always 3. So 3 plus square root of x minus 1. And again, that same piece, square root of 1 plus 1 over 4 minus 4x minus 4 dx. And that gives us the surface area. So we're finding the circumference, 2 pi r, circumference of these circles, and then timesing those circumferences by that arc length to get our surface area. Alright, last one here, we're going to actually revolve around something the other direction, so we're going to have to do things in terms of y. This is one place where you don't get another cool method that can help you avoid doing things in terms of y. So we're actually going to go around x equals 6 this time. So that reflection is going to be right there. So we're revolving it this way, so finding the surface area of this type of a shape. I'll put it right here if you guys can still see that. Yeah. So 2 pi, this time in the x direction we're going from 0 to 2, or in the y direction, sorry, we're not in the x direction, 0 to 2. The radius is going to be this length here, which is 6 minus this length here. And we're going to have to actually figure out that. Our original was this. So the derivative, or the changing it so that it's in terms of y instead. X equals y squared plus 1. So 6 minus x squared plus 1. It's 6 minus all of that. Oh, but it's not x squared, it's y squared, sorry. We're trying to do everything in terms of y here. So 6 minus y squared plus 1, because we changed this so that it's in terms of y. 0 and 2 are in terms of y. And then we have our length, our distance thing here, which we're going to have to redo now in terms of y. So it's going to be 1 plus the derivative of this. So the derivative of this is 2y. And then squared. So in that case, this piece turns out a lot nicer. We can simplify that one just a little bit. We probably could simplify this as well. I usually don't. I'm not really sure why. Oh, and you can't see my end there, the dy's. Okay, so if you did simplify this to like 5 minus y squared, that would be fine as well. So when we're doing these problems, the lengths and surface areas are often like irrational, and the expression is usually really difficult to integrate by hand. So for any of these on your final or something, it might be a multiple choice where you just pick which integral looks the way it needs to look, and you wouldn't have to actually calculate that by hand. So for your assignments on this, you've got a worksheet on this. On your review, your test, just go ahead and use Desmos or some other integral calculator to actually calculate the numbers on these ones. And then mostly I'll just be looking for your setup, but it's also a good idea to get those actual numbers just to make sure that the number makes sense. It's also how you're going to be able to check your answers with the book and with the worksheet. I can take a picture of the answer key to the worksheet if I don't already have one posted. Look in the files, there could be one there. Also, Lauren took pictures of lots of answers of different things, so you could check with her for answers if I don't get something posted. Thanks, guys, and good luck. Please, again, continue to let me know if you have any questions.